Good morning. How's everybody doing out there? So, welcome. Yes. Oh, look at that. We got some hilarious green screening going on. Let me crank up a couple of things. That should pick that up a little. Yeah, you can see the green screening doesn't work when I've got a bright white background. That's all right. We can fix that. How's everybody doing out there? So, yes, Restream was having a little bit of a moment. It's like you're online, you're not online, you're online. There are 7 people watching you and 0 people watching you all at the same time. And you're connected and you're not connected, and now we're disconnected, and I'm not quite sure what's going on. But folks, if you're out there and you're alive, drop a message in the chat and let me know that you're out there, because it's nice to have people in the chat. And we're doing Advent of Code. So yesterday I did part 6. And I got it was day 6. I got part 1 done on the stream, and then we were playing around with day 2. So Renee's here. Hey, Renee, which is I guess means that there is intelligent life out there. Well, I say intelligent, it's Renee. But so yeah, yesterday, Advent Code day 6, part 1, not too difficult, a bit of fun with that, and then part 2 turned out to be a lot more complicated, and then I went out in the afternoon and got back late last night and was like, I'm going to have another look at this. So let's take a look at what I actually did, because the solution to this was kind of interesting. So this was the problem for day 6, part 2. If you remember, yesterday's problem was about a guard walking around a grid. So if we spin up Advent of Code, let me get, I don't want an AI summary, I'd like a website, please. There we go. So yeah, you have this little map of your puzzle input, and that was fine, and that was fun, and it worked. And then the second part was like, how many points in that grid can you drop an obstacle to cause the guard to end up in a loop, going round and round and round and round and round. And, pardon me. And so I started off by looking at, could you could you analyze the grid and look for all of the places where you've got like 3/4 of a loop? And then I realized that loops aren't necessarily going to have 4 corners, because you could have like a sort of, like a figure of 8 style loop. There's all kinds of different loop things, or like a L-shaped loop. So that didn't work. So I started thinking, all right, what if at every point on the path you look at wood turning at this point, because when you hit an obstacle you turn 90 degrees clockwise. So I was like, okay, if you analyze it, so at every point on the path, if you turn at that point, then that's going to give you it's going to give you a loop. And then I realized there's a couple of places where, because originally what we were looking at is, does it happen every time you cross your own path? But then I realized there's a couple of places where you don't cross your own path, because if you create a loop at that point, the loop it puts you on is going to connect you to the origin point. Like if you look at the example input.txt here, if you looped at that point there, for example, you're not following... yeah, that one in there. You're not crossing your own path, but that starts to go north, at which point you're going to meet your origin point, so you are going to end up in a loop, and you're going to end up following that. Where's my thing gone? There we go. That's better. Restream chat got confused. Hello. There we go, that's nice. And then I thought, well, okay, what if you just, you take your route around the grid, and for every single point on your grid, Rat's telling anyone says, oh neat, I wanted to do Advent of Code for the first time using my own scripting language, then I realized I didn't have arrays yet. So I added arrays to Rockstar a couple of years ago for exactly this reason. I was using it to do Advent of Code one day and was like, oh, I can't do that because the language doesn't have the feature I need. And I was like, well, it's my language, so I guess I could probably plug that in. Hello, Smab UK, welcome to the stream. And yeah, it's amazing how many more rabbit holes you have to go down when the language you're using to do the thing is the language that you maintain, because you can add stuff to it. Anyway, so what I figured out with the way that the grid works was that if you take every point you cross and say, well, if I turn right at this point, and then just play the game from there, do I end up in an infinite loop? And so the logic I came up with for detecting an infinite loop is if at any point you end up moving in the same direction on a square you've already visited, moving in that direction, then that indicates that you've found a point for it. And actually, let me just, I had some visualization in here, and I took it out to make the code look a little neater. But let me just plug the viz back in, and then I can just walk you through and show you the solution, because I'm quite kind of happy with how it came out. So let's put a, so what I got here is a bunch of extension methods on a two-dimensional array, so that we can basically treat the grid as though it's a class without actually making a grid class. So let's have a public static void dump, and this dump is a horrible word. Render is a much nicer. This char dump grid. And so what this is gonna do is we're gonna say for public needs an I in it. For var I equals naught, I is that, no, not I row, R. For row equals naught, R is less than grid dot count. It's length because it's an array. Arrays have a length, lists have a count. Thank you, .NET. That doesn't confuse me twice a day. Good morning from Germany. Quel jour, camarade, which, if I remember my German, that's not a German name, but hey. My solution for part 2, yeah, it's you get some really cool optimization out of it. I think mine was 300 milliseconds when I finally ran it at the end. So let me show you the viz, and then we'll turn the viz off and we'll run that. So that's R++. And this is going to be for var c equals naught, c is less than grid 0 dot length c++. And let's just do a, so first of all, we'll just console.write grid rc and bail out of that, and then console.write line and bail out of that and bail out of that. And so I think now we can stick a console.clear at the top of this. I got to read of a 47-page document before Monday, so you might end up just being background noise. A large group of people need to check a Word document. Why didn't the person put it on SharePoint? I feel your pain. Yes. And you're using Word screen reader so you can get through it quicker. But most people, every time they gotta add a comment, I have to start. That sounds. I'm very happy to be background noise for that. I will try to make calm and reassuring and supportive noises. It's going to be all right. SharePoint can't hurt you. SharePoint isn't real. That's a lie. SharePoint can hurt you. It's totally real. All right. So I think that if we drop that in and then in here, while true, so that's that, and that's going to render the grid at every point, grid.render. See what this does, because visualization is fun. Algorithms is all right, but it's really nice when you can see what the code is actually doing. There we go, and .NET Run. Oh, hang on. Actually, yeah, that might work. Such animation. Good morning, Finland. How are you doing? Okay, the visualization here is not working terribly well. But let's just try. So we'll do, that's part 1, that's part 2, and then we'll just do a grid.render on the end of that just so you can see the final output from it. Yeah, pretty good. All right, let me take that. Where was that other grid.render? Take that one out. Hello, a Kiwi. or AccuE. So, I've got a console.clear at the stop of my render method. That can come out. That's no good. We don't want to... there we go. All right, 8 milliseconds for part 1, 386 for part 2, and the rendered grid is there, but I'm not filling the blocks in. Yeah, it's 5 a.m. in the States. So Advent of Code is one of those things that drops at midnight New York time, which means that anybody wanting to get on the leaderboard in Europe is basically screwed, because you've got to be up at 5 a.m. So this is my way of kind of giving it back a little bit, redressing the balance a little. Anyway, so yeah, day 2. Basically, the technique that I found is, first of all, you solve part 1, and that gives you your path, and then you take every point on that path, and you're like, right, if I started from here, would I end up in a loop? And you detect a loop by marking the direction you traveled through every cell you visit, which is this grid point row point column equals direction. And if you pass through at the same point, again going in the same direction, I don't think it's bulletproof. Like, I think there's one more optimization, but honestly, for 300 milliseconds, I'm gonna take it. So all right, let's push that up. Git add dot get commit minus m viz on day 6, part 1 and 2. All right, hello Christian Florentin. You watch all my videos. Cool. It's nice having people watch videos. It makes it kind of nicer making them. Once in a while I get little emails from people going, hey, I like this video and I watched the stuff and then I saw this one. And what's really nice, sometimes I'm having days when I'm like, I don't want to make a video today. I don't want to. No, I'm tired. I'm fed up. I don't have any ideas. And then I'll get email like that. And it's like, all right, people are enjoying this. Maybe I should do another one. The next YouTube video I'm doing is the history of IBM, which I thought, yeah, how hard can that be? IBM was... So, Jake, I decided that I'm not going to try and stream when I'm away from home, because I was away in the Netherlands for 3 days this week. And, yeah, it's just the logistics of you're in a hotel room and you just got a laptop, you don't have a proper camera, you don't have another screen for the sharing and everything. And I decided that when I'm away from home, I should probably be concentrating on the reason I'm away from home, which was an event I was doing last week. So yeah, I'm going to do Advent of Code every day, and days when I'm at home, I'm going to stream it. And yeah, Christian, the AT&T of the computer. So IBM is just like, I mean, the company has kind of evolved consistently from... So, small dominoes, Jacquard loom, big domino my 80, having a ruler of 80 characters. The Jacquard loom didn't use 80 characters, it used 45. One of IBM's biggest innovations, like the first sort of fundamental paradigm shift in compatibility was because IBM, their tabulating card business grew out of a company called Hollerith. And this is going to be spoilers for when I get the IBM video done, which ain't going to be Monday because there's way too much history to go through. But yeah, the Hollerith tabulating cards used 45 columns because the holes in them were circular. And it was in the 1930s that IBM were like, we need higher information density on our cards. And so they overhauled their entire line of equipment, their key punchers and their tabulators and their card collating machines, from 45 columns to 80. And that's where the convention of 80 columns comes from. So yeah, your 80 column IDE, that does go back to IBM in the 1930s, but it was IBM that introduced it. I do not believe, from the source that I'm reading at the moment, that the Jacquard used an 80 column card. Let's check it out. We're on the internet. We can fact check this, can't we? Jacquard loom card. If it's 80, then... the programming story of the Jacquard loom. We want a, yeah. That's a Jacquard loom card. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. There's a Jacquard loom. If any of you folks ever go to Berlin, there's a technology museum in Berlin, which is just amazing. And one of the things they have in the museum there is they have a... no, I for IBM is not out already. I'm still putting it together. They have a working Jacquard loom in one of the lobbies there that actually runs, and you can watch it going. And it's amazing. But yeah, the original Jacquard loom, these are the cards that used, and they didn't use an 80-column pattern, they used something else. So yeah, it wasn't Jacquard, but the original Hollerith machines had 45-column cards, and then IBM were like, if we use square, rectangular holes instead of round cards. Yeah, this is a text file from earlier than 1900. Jacquard was 1804. So yeah, it's almost 100 years earlier. So we had Jacquard looms around 1800s, and then the first tabulating card machines in 1890, and then the first electronic data tabulating machines in the 1930s, and in the first microcomputer micro or relay based what were the things, but valves, things before transistors. Yeah, Berlin rocks. Berlin's awesome. Anyway, right. Let's do Advent of Code Day 7, because how hard can it possibly be? Advent of Code 2024, Day 7, Bridge Repair. The historians take you to a familiar rope bridge over a river in the middle of a jungle. The chief isn't on this side of the bridge, though. Maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross it until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators from their calibration equations. Tom, yeah, I got the second star from Day 6 late last night. I decided I didn't want to get left behind. Otherwise, I got catching up to do. So yeah, I did that one off stream last night, but the code is in GitHub if you want to look at it. They could finish the calibrations if only... Hello, Southern Germany. Welcome. Yeah, you skim read this. Historians, rope bridge, elephants, yay! Elephants playing near... Okay, let's backtrack. Stole all the operators from their calibration. They could finish the calibrations really soon, on which test values could possibly be produced by placing any combination of operators into their calibration equations, your puzzle input. For example... I should see the Blue Sky post that I've just been tagged in. No. Do I? Yes, need sound on. All right. Am I capturing audio output? Let's have a look. That's nice. That's beautiful. I love it. All right. All right. The stream is now going to get blocked for a copyright violation, because that's what happens. So any folks watching on YouTube, you want to get over to Twitch quickly before YouTube goes, crimes, and shuts it down. All right, each line represents a single equation. The test value appears before the colon on each line. It is your job to determine whether the remaining numbers can be combined. Okay. No, it's fine. Don't worry about it. I've had streams blocked. So one time when we were doing, online conferences and stuff during the lockdowns, I was doing a sound check for an online, concert I was doing. And I bashed out, maybe 30 seconds of AC/DC, just me playing a guitar on Highway to Hell. And YouTube's algorithm picked it up and said, it's a copyright share. I was like, wow, wow, they can detect that from 30 seconds. But also, as a musician, when you play something and the computer goes, oh, you just played AC/DC, I'm like, oh yeah, all right, I got it. All right, so, so this is about, can you insert operators? Okay, all right. So we got to go through every line in the input, and we got to figure out, can you turn those numbers into that number just using addition and multiplication? So I'm thinking this is gonna be, so right now we got 16 people on YouTube and 24 on Twitch. So Twitch is winning. Twitch 24, YouTube 16. All right, so I think what we gotta, this is gonna be some kind of a searchy tree kind of a tree thing. Because what we basically got to do, we got to be, okay, so 10 plus 19, did that work? 10 times 19, yes, okay, boom, done. All right, this one, 81. So let's do, actually, no, we don't need to do it as a tree. So the problem space is going to be binary. So 8140 means we got two gaps. We got that gap and we got that gap. And each gap can have two potential values. So that one, we've got 81. So we got plus, 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 times, times, plus, times, times. And we just go through them in that order. And I wonder how big that's going to be. Let's have a look at the problem input. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, not, yeah. All right. So I think I can probably do this just by writing a function that will take a list of integers and will rattle through, you have plus one gap, the gap from last to first. No, because it's always evaluated from, always evaluated left to right, and numbers cannot be rearranged. So you can only, well, my reading of the instructions is you have to put exactly one operator in every gap from left to right. All right, let's try it. So let me grab the example. And .NET new console -0 day 7. So we'll do it in .NET, and if it's easy in .NET, we're going to do a bit of digging and do some Rockstar. Maybe today's in Rockstar, maybe one of the others in Rockstar. Today's could be fun in Rockstar because of arithmetic operators and stuff. So, CD day 7 and... Yeah, Twitch is a better streaming platform than YouTube. YouTube has a certain amount of traction. But, you know, fundamentally, YouTube is a publishing platform that also does streaming, and Twitch is a streaming platform that also sometimes does publishing. And when I'm watching stuff live, Twitch streams as a viewer tend to be just much better than YouTube streams. So, all right, so we got our program.cs. You'll notice I've fired up full Visual Studio, not VS Code for today. Because yesterday got to the point where I wished I had better refactoring tools than the ones you got in there. All right, so let's, we got to read all the things. So, come on. File.read all lines, example.txt, and then each scenario is gonna be, there's always this thing with .NET where you're like, do I start making classes or do I do the whole thing using dictionaries and strings? And I think I can probably dictionary this one. So lines, so let's say var, what do we got in cases? Cases will do. File.readAllLines that dot to dictionary, and then each line we're gonna say, yeah, 16 seconds on YouTube, 5 seconds on Twitch. And I think I can probably bring that lower. I'm going through Restream here, so I can stream the same onto both platforms. But if I get to a critical mass where there's consistently like twice as many people on Twitch as YouTube, maybe I'll stop doing YouTube streams. I don't know. So anyway, so file.readAllLines that, and so each line is gonna be .select line goes to line.split on. Let's have a look at our text file. Yep, that's fine. Save that as example.txt. There we go. So we got a split on a colon space and then split. Actually, we did split on colon for this one. So that'll be one of those. So that'll give us the first part and the list. And then we're going to select that on pair goes to... Now, at this point, I'm actually going to do to dictionary. To diction Marty, because typing is hard. Come on, come on. So to a dictionary, select line.split, and then pair goes to pair 0, and we need to do an int32.parse that. I'm assuming they're not going to give us anything bigger than a 32-bit integer. Generally, when Advent code won't fit in a 32-bit int, it means you've messed it up. So that'll give me the dictionary key, and this will give me pair 1, but that one I want to split on a space dot select, and that is going to go int32.parse, and that is going to go to list. All right. So now for each of our key, for what do we got? So it's the solution of the answer and inputs in cases. Right. See what we can see. See if I can remember how tuple. No, don't run Visual Studio again. No, wrong, bad. All right, .NET Run. That's what we wanted. Cute. That will be because there is a blank line at the end of example.txt. Normally? No. All right. Weird. I need string split.remove entry and there. So I'm already splitting on colon here. So first we split on colon, that splits each line into the answer and the numbers. And then we take each of those pairs and we turn it into a dictionary where the key is the answer, parsed into an int. Split on colon space. Yeah, yes. Nice, thank you. Yeah, that's nice. Also, hint, don't make it a dictionary. All right. Targets repeat. Oh, sneaky. Ah, thank you. I would not have spotted that until we got into... let me have a look at my puzzle input, actually. All right, so that means I need a thing, which is a thing, which is a... All right, so not a dictionary, so we need something that is a... what are they called? Let's look at the ubiquitous language of the problem domain. Equation. Public int answer get set equals 0. Actually, 0 is a default on that. And public list of int inputs get set equals that. And there's that, and there's that, and there's that. And list of tuple and number array number. I'll do it as an equation class. And then I can put a string line in there, which means I can put a primary constructor on this, and Primary constructors are one of those things I really am not certain about. So Tom says, do all the answers fit in an int? As I said a second ago, in advent of code, if you overflow int, it normally means that... I've never seen a problem yet where you needed like 64-bit arithmetic or big int or arbitrary precision to solve it. There's always been a solution that works with ints. All right, so string align, and this is one of those weird things like a primary constructor. I need to mangle line up here inside a function. So I'm going to do public equation string line. So what I want to do here is I want to say var pair equals line dot split. What? Var answer. So this dot answer equals pair z1. Where is this autocomplete bollocks coming from? I know what I want the computer to do, and the computer's like, no, you will have this arbitrary bit of the .NET runtime that you have never seen before in your life. Yeah, fine, shut up. So this dot inputs equals pair 1 dot select int32 dot parse dot to list will do for that. Okay. That needs to split on space, doesn't it? Dot select parse dot to list. All right, so now equation is a little class that represents the answer and the inputs. So file.read all that dot select line goes to new equation line. All right, there we go. So that's nice. And then for var eq in equations. So what I'd love in every IDE ever, I want a thing that says, I will do the typing. Never, ever. There are several targets which are greater than max int, so unless they just happen to be valid... What? There are targets bigger than max int? Let's take a look. Let's get my puzzle input. Ooh. Fruity, yeah. Okay, I take it back. Advent of code will absolutely throw chunky precision arithmetic at you. So where are we now? We're in day 7. Let's day 7. This is my input.txt. All right. Can we do equation of t? No, we can't. Not really. Not unless there's a new set of iNumerics interfaces in .NET 8 and above. But we'll just replace int32s with int64s. So there's that, there's that, there's that, there's that. And it wants me to use longs for those. That's ignored, so it doesn't matter. Nothing more than ints till we hit double-digit days. Yeah, I could get behind that. That'd be a nice way to do it. So let's just do a toString on here. Override toString, and this is gonna return dollar bang answer, and then string dot join inputs. I need a separator for this, don't I? And that can be an expression body because I love expression bodies. They're so pretty. And there's that, 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 and that's good, and that doesn't need to be there. And so now for var eq in equations, console.writeAlign eq, let's see if we have parsed our input correctly. All right, looks pretty good to me. Okay, so let's do a quick git add all the things. Yet commit minus m parsing input works so far. Git push. Just in case, you know. Does C# automatically change types when you do things like, I assume slash is division there. Change types is the wrong way of referring to it. In C#, like an integer divided by an integer is always going to be an integer. So if we do like console.writeLine 10 divided by 3, console.writeLine 10f divided by 3f, it does a thing called type coercion. So if we divide floating point 10 by an integer 3, or if we divide a integer 10 by a floating point 3, and nope, not that. .NET run that. So yeah, you can see here, if we divide int by int, the answer is always int, but if either of the arguments is a floating point or decimal, it'll coerce the result of the entire operation to be the most precise type involved in the inputs, which generally works pretty well. It's never given me that many surprises. Rat's Tail 91 hates the Christmas heat in Australia. Swap ya. I'm in the UK and we are getting battered by Storm Dara right now. There are 50-mile-per-hour winds and the rain is going sideways. It is hilarious and kind of scary if you're living in one of the places that's getting hit really hard. I got friends down on the south coast and in Cornwall and they are not having a good time. All right, so we're parsing those. So now the question we've got is solvable. Public bool is solvable. So actually, we can just do solvable on that, can't we? Yeah. All right. So what does solvable look like here? So we got two operators. We got multiplication and we've got addition. And what we got to do is figure out the combination. So I can think of two ways of doing this. One of them is to kind of use string manipulation to build an expression, which is going to be easy because it's just this plus this plus this plus this, like string concatenation, and then run an expression parser. And the other one is going to be a kind of go through and enumerate all of the possible combinations and plug all of those in. And all right, so what we got is we got a bunch of inputs. 1, 2, 3, which means we have gaps there and there. Which means we, yeah. Recursion would be interesting because recursion, what you basically do is you take the first pair of inputs, you multiply them first pair of inputs, multiply those, and then say, right, well, if we, yeah, actually recursion would be a nice approach here, because what we're effectively doing is taking each pair, collapsing it to a single number, and saying, if those numbers were this number, would the thing be solvable? And all right. Yeah. Okay, so we're going to try a recursive approach here. Now, disclaimer, when I try and do recursion, about 80% of the time it works. The other thing, I turn my brain inside out. different size matrices of the inputs on both axes and fill in the gaps by alternating plus and multiplication. Now, we're going to try recursion first. So what we got here is, so our base case for recursion is going to be so we got exactly two things, then so if inputs dot length is 2, then if inputs 0 times inputs 1 equals answer, return true. If inputs 0 plus inputs 1 equals answer, return true, return false. Additions on everything. If the value is too low, change the first one. If the value is too high, revert and flip the next one. I'm gonna do recursion, and if recursion works, then I'm gonna ignore all of your delightful suggestions, and if recursion doesn't work, then I will consider all of your suggestions. But I think this is probably gonna work. So let's value is too high is good for an early exit. If inputs count as 2, that. Otherwise, we are gonna return yeah. So it's always left associative. So we go down to input counts equals 2. Otherwise, what we need to do is we need to create a new list. Right, try this. Has anyone mentioned that if the last number is not a factor of the total, then the last operator could only be plus? Oh, that's interesting. Right. This is all smelling very much like premature optimization. I'm going to get it working with recursion first. Public static class list extensions. Public static bool solvable this list of t tollable t, this list of t list, and t result. So what this is going to do is I'm basically going to crunch that thing here to be if list all right, this is going to assume that list always has 2 elements, but it's advent of code, so I'm not going to bother doing error checking on that. If list 0 times list 1 equals result, return true. If list, why is that complaining? What's the numeric constraint? Numeric. There's a thing. There's a there's a whole interface thing you can constrain stuff with, and I remember this because I saw Mads Torgersen doing a presentation about it in Denmark about 18 months ago, and that was a long time ago, and I've forgotten some stuff since then. Is numeric? No. Math.net numerics? No. Fundamental numeric types. Kagi is a search engine that is you pay for it and you get search results with no advertising and no AI generated bot shit and no crap, and they license Google's index. so they get the same accuracy and kind of breadth of search as Google, but then their business model is you give us money for good search instead of we will sell your eyeballs to the highest bidder. So generic math, this is what we want. T is an I number of T. That's it. That's it. I think. Yes. So I number here is a constraint that says this can be generic, but it's got to be a generic that you can do maths with. All right. So list extensions there. If inputs dot count equals 2, return inputs dot solvable. Answer. All right. So that gets us down to the case where we've only got 2 things on there. Now, if I do an otherwise return false, let me just run this through, because our example.txt has got a couple of little things in there. So let's do a, for that in equations, console.writeLine eq plus stem. No, let's do it the other way around. eq.solvable plus dem plus eq. All right, so this is going to toString that. There we go. .NET run this, see what we get out the other side. We get you can't write programs properly because you're an idiot. Program.cs line 8. Yeah. Cool. Okay, so the first case works because where we only have a single pair, we only got 2 arguments. That one's true and that one's false. Okay, so now what I need to do is to crunch in the next case here, which is if inputs.count is not equal to. So now public static bool. Now this is where the recursion bit is going to get a little bit gnarly, because this is where we get this sort of proliferation, because every case that doesn't solve, it's now got 2 cases to feed into the recursion. So yeah, we're going to see how bad this gets. Public static, what's this going to do? It's going to turn a list of t reduce t. And so what this is going to do is take this list of t list, is it's going to, now that can actually be an IEnumerable of list of t, because the first thing I want to do is to yield return new list of t, and the list is going to start with 0 times 1. Yep, use a collection expression. Oh yes, we like that. Yield return list.that.concat list.skip2. .toList. Now why is that complaining? Because I need the numeric constraint on the t, because that needs to be a one of those. And that doesn't like that. There is no target type for the collection expression. Well, there was, until you told me I didn't need it. Yeah. And then we'll yield return the same thing. All right, so that will now give us a return inputs dot reduce dot any L goes to L dot solvable answer. I think. So that's going to crunch that one down, which means that one is going to... So let me just give us a little bit of visibility on what's going on here. Console.writeLine, string.join. No, run it, see what happens. All right, so I got 2 trues out of that one. Is that correct? I honestly don't know. Let's have a look. No, it's not. Okay, so I got the 3267 out, that worked. But it hasn't picked up the 292. 11,616. Where's that 20 come from? Ah, no, hang on. Yeah, 11,616, 20. There is a bug in solvable. I have, yes, I do. Thank you very much. Yeah, all right, let's try that. Still not quite right. Weird. All right. Okay. This is my favorite part of Advent of Code, is where you go, that's funny. So we got 11, 6, 16, 20. It says that's unsolvable. Now there is a solution there. And the solution there is 11 plus 6 plus 6 times 16 plus 20. All right. Let's try this. Just a bit of visibility, give me a little bit more insight into what it's actually doing here. So console.writeLine, and so we're going to do this. We're going to do a string. So this is going to be list. Is reduce not being called enough before solve? Well, reduce should only need to be called once because it yields multiple solutions. Hang on. Yeah, no, hang on. The recursion's in the wrong place. Yeah, Adam, all of my solutions are on GitHub. I'll drop a link in the what's name here. GitHub. Yes, Android X, you are exactly right. The bit that does the recursion has accidentally been moved into the wrong place, so it doesn't actually recurse itself. What this should be doing is that should be returning inputs.solvable on answer, and then this chunk of code here should be saying if list.count equals 2, then if that is that, if that is that, return true, otherwise return false. Otherwise, return list.reduce.any where L is L.solvable on result. Yeah, let's flip that around. And that should actually be if that is greater than 2, return that. Okay. And actually we can crunch this down another level, I think, because thank you, Adam. I do enjoy doing talks. It's a kind of weird introvert-extrovert balance thing. I'll have a week when I sit at home at my desk and I come up with ideas and I talk to nobody. But then you go out and talk to like a room full of people about what you did when you were sat at home not talking to anybody. And this we can actually say if list.count equals 1, hang on, test it, then optimize it. All right, all right, all right. I like that. What do we think? Punch it through the real input and see how long it takes. And just because. So what's the actual answer we need to get out of it is we need the total calibration result. So let's take that out. Var part 1 equals equations dot sum where e is e dot Catalan Stan, hey Dylan, is the order of executing the operation taken into account like parentheses around star and slash? Are you asking about advent of code? Because there are no parentheses or slashes in advent of code. I used to work in an office, Sally. It did not work out well for the office. Just for fun. Now you can tell I'm an optimist because I'm outputting the time in milliseconds instead of like minutes or hours or days. Yep. 148 milliseconds. What are we thinking, folks? We feeling lucky? Boom. Awesome. Right. Let's look at part 2. Now let's crunch it first, then look at part 2. So what I think we can do here is we've got this duplication of that thing and that thing there, and that's going to yield return both of those, which actually means that if list.count is not equal to 1, we can do that return list.0 equals result. So that way what we're doing is okay, so Catalan Stan, read the instructions. So we're doing advent of code. We're doing advent of code day 6 or day 7, which explicitly says in the instructions that Operators are always evaluated left to right, not according to precedence rules. So yes, you would appear to have just jumped in and lost the context. And also, like, if you didn't know we were doing Advent of Code, did you think I was just writing calculators for fun? So yeah, it's Advent of Code, and operator evaluation is left to right. That's in the puzzle brief. Okay, so we can crunch that down. Yeah, and we'll say if that is greater than 1, we crunch it. Let's see if that still gives us the right answer. Yes, it does. Wow. I'm just looking at the variance in the runtime. Did that get slower? Yes, it did. All right. I know what it did. I know what it did. I think we want to do that first and then that, because addition is probably cheaper than multiplication. And we'll do that, and we'll do that. And then I think this should come down a little. Okay, so that's still 129, 128. All right, but now I think if we do that and no, it's going to be faster because we're eliminating an additional concatenation step, because this is expensive. List.concat is going to allocate memory, give you a new list, copy all the things into it. But you know what? Actually, I like the other one better. This to me is more pleasing. For each var result in, and I'm going to do this too. No. Sometimes a for each makes it much easier to see what's happening. Actually, I'm going to do this. Var sum equals that. No, I'm not going to do that because that would mean we were doing it things we potentially didn't need to do. All right. Yep, and that needs to be a list because we're using a count on there. All right, .NET Run, check we get the right answer out of that one. There we go. Yep, okay, so eliminate duplication and pay 130 milliseconds for the privilege push. I should put days on the commit messages, shouldn't I? Yeah, I'll do that. Right, let's look at part 2. I just put the answer in there, didn't I? No. What? Yeah. Yeah. Reload. Okay, good. Your first pass is from the... Oh, fruity. The concatenation operator. Ha, yeah, cool. All right. Oh, I like it when it's like this. All right. All right. All right. All right. All right. Okay. It's going to be fun. Uh, so, uh, So the quick and dirty sauce. So what I'm actually going to do, just to make this nicer, is I'm going to just split this out a little bit. So what I got now, reduce is going to take a list of T, and it's going to take a list of func of T reductions. Okay, so the part 2 problem is exactly the same puzzle, but in the first part, all you could do was add numbers, like arithmetic addition or arithmetic multiplication. In the second part, they've added another operator, which concatenates digits and turns the result into a decimal. So 12 pipe 345 will be 12345, or 12,345. And so now, when we test all of the possible permutations, we are going to need to punch in that additional option for what we can do on that. So for this one, for var reduction in, and I'm going to hoik that out of there. Reductions. Okay, I think that can come out. It does need a new list. Yeah, that'll do. All right, so what we're going to do now is we're going to pass in a list of all the ways we've got of combining the first two elements in case that yields the result that we want. So for this one, we're going to say for var, we'll call that one there reduce. And solvable this t result and a list of func of t reductions. L dot solvable and why is that now complaining? Solvable has two parameters but is invoked with one argument. Yeah, I just need to pass that down, don't I? Yeah, advent of code is fun, isn't it? It's really, really fun. It's nice being able to write code that, you know, nobody is going to ping you on Slack on Monday morning and go, you need to come back and fix this. So yeah, Anoredex, I'm doing exactly the same thing here. I'm going to pass in a list of solvability operations. So first of all, let's just do that, and inputs.solvable list of func of that needs to be a T now, doesn't it? So that needs to be generic because I need the constraint on it of I number of t. All right, and inputs dot solvable of t. Why is that complaining? Come on. Yep. 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 Oh, because I'm not using a... no, I can't do that because I... right. Okay. All right, back it all up. Back it all up. Back it all up. That's not going to work. So the reason is that this... I can't use the I number of t constraint to expose... Does I number of t expose pars in .NET? It does. Does it? Ooh, maybe we can do this after all. So we can have an equation which is a generic type over t, where t is an I number of t, which I think, can we do a t dot parse once a... read-only span or system.globalization.number stuff. We need to provide a... no, hang on. So that needs to be a t. That needs to be a list of t. So the explicit interface implementations, there is a parse on here, but it wants a read-only span of byte, which should be coercible into a string. Okay, so that'll work if we put the... Is it getting better? Is the question. Is this nice or is this filth? I think it's filth because there's no point making this generic if we're only going to use it one time. And so what we're actually going to do here is, there's our list of reductions. And that one wants me to, inputs.solve, but that's gonna inputs.solvable int64. Will that? No, that won't let me do it because now it thinks that's a that, which means this needs to be an int64 to an int64 to an int64. So we got a function takes an int64 to an int64 to an int64, which means that type argument is now redundant, which means all of those should be longs. Yep, okay. And that type argument is long. Okay, right, we're getting somewhere. One-time use garbage code for the win. Oh, C# type system is the type system itself, I think, is very good. The difficulty is with generics. Because actually the difficulty here is just deciding whether generics is the right solution for the problem I'm looking at or not. So now what I want to do is I'm going to create a list of functions which are long, part 1 reductions equals, and now this is going to be a new list of long, and it is going to have A, B goes to one of those, long A, long B goes to A plus B. All right, and now I can probably get rid of a whole bunch of stuff. So that can be a collection initializer. Those type keywords can come out. Okay. Yes, all right, you can have that. Okay, let's see if that does the same thing. Cool. All right. So this is refactoring part 1, because now that we've got part 1 plugged in, git add dot git commit -m day 7 refactor part 1 to take a list of operators and push that. For part 2 operators equals part 1 operators dot concat a b and yep, that should be a. So what do we need here is we're gonna have a int64 dot parse a dot to string plus b dot to string, and at least one of those two strings is probably redundant. And why does it not like that? I'm curious as to why I can't concat that. That should be fine. One of those can go because it'll implicitly pick it up from the other one. That's the operator. Let's try this. Func long concat equals that. Of course, it wants a list. Do I bother with concat, or do I just make another one? Or is there an option to add a thing to the end of a list? Yeah, there is. We can do. Can we do that? Except that works in place. I want the list with the new thing added to the end of it. Things that operate in place, like add and sort, they yeah. All right, you know what? We'll do it this way. Operators.add concat. Is there append? Yes, beautiful. Thank you. For okay, operators is complaining now. There. Ops2 equals operators.append that. Stopwatch.restart, so we can see how long part 2 is going to take. Scrub that. Part 2 equals equations.where solve on ops2. Dot sum that. Stopwatch.stop and part 2. And now what? There. Oh, that's nice. You can actually make it a function, and then you can pass the function into... Yeah, that works. All right. All right, we'll try it on the example first. No, that's a git push, not a .NET run. 11387, day 7, advent of code 11387. All right, I'm thinking this is probably okay if it runs in reasonable time. All right, not too bad. Woohoo! Sweet. All right, that was fun. Right, git and then make it nice. Git add dot git commit minus m day 7. Done, part 1 and 2. Yay! How long did day 6 run for you? 300 milliseconds. Okay, 400 milliseconds on this one. Yeah, for part 2. So the secret to the optimization on part 2 is the approach that I took. Every point along your journey, you say, right, if I turn right here, so if I put a block there, basically it takes every point on the journey, adds a block to the grid, and then uses that new grid to run the entire game. But the second you cross a point that you already crossed moving in the same direction, no, we're talking about yesterday. We're both talking about yesterday, part 2, day 6. Yeah, it's always fun when things, when memoization makes things go slower, isn't it? And every kind of optimization has an overhead. So yeah, basically what it does is for each candidate that you could put a block in, so I had a method with block at. So basically the code says if grid with a block at block has a loop from that origin, then add it to the list of blocks. And then has loop just checks whether it's not actually backtracking at any point. It just keeps a record of every square you visited and what direction you were moving when you visited it. And if you ever end up back in the same square moving in the same direction, that means you're on a loop, and so it bails out. And I think there's a couple of points where it doesn't pick up the loop the first time because it crosses itself in a different direction, and so the direction's changed. But then the cell after that, it'll pick it up. But yeah, I was kind of quite happy with that. All right. Anyway, right. Let's close that. Let's close that. Let's close that. Let's close that. And let's have a look at the code. Where's my Visual Studio? Is there? Yeah, save. To list that just to get rid of the thing. All right, so that's in list extensions there. Is this reducible any further? So I think it'd be fun to do some Rockstar while we're on the stream today. And I'm wondering, of the ones that we've seen so far, let me spin up VS Code here. And so day 1, I got a work in Rockstar in that, but the Rockstar on that was using bubble sort instead of a quick sort, so it took a little while to run. What did we have for day 2? Was all done using extension methods on IEnumerables. Day 3 was regex parsing. Day 4 was Yeah, do not show for this workspace, that's fine. Day 4 was the word search. Day 5 was the what was day 5? Oh, day 5 was the page sorting stuff. What the heck? All right, let's try and so what I'm gonna do is I'm gonna see if I can convert this solution into the same thing running in Rockstar. What was that? Actually, no, I'm not. I'll tell you why I'm not. Am I? Am I not? I don't know. Yeah, we are. Rockstar's got arbitrary precision arithmetic, or not arbitrary precision. Rockstar's got big numbers. I think. I should know that. I invented it, but you know I've been busy. So there's my answer there. Code with rockstar.com. Try it out. Dome plus dome. Yeah, cool. Rockstar goes to 11. Rockstar, in fact, goes to arithmetic and numbers, variables, simple variables, pronouns, types, and values. Numbers in Rockstar are fixed precision IEEE 754 and go from their 128-bit fixed precision decimals. So you get 29 digits, a minus sign if you need it, and a decimal point you can put anywhere you like. So that is the numeric range on Rockstar. It goes from 0.1 up to 79 bazillion jillion grillion. So yeah. That was fun. So yeah, we have the numeric, we got the numeric scope necessary to do it. Now, before I do that, I just want to do a thing because there's a pull request open on Rockstar that I want to merge, or there should be a pull request. There's definitely a branch. Have I ever heard of your language toy? I have not. I mean, I've heard of I've heard the expression toy languages, but I have not heard of the language toy. Where is toy? How do we find out about toy? Boom, new editor. That one, let's pull that branch. So, Z rock. Yep, pull that. Please update your changes or stash them before you merge. Git stash, git pull, git checkout, new editor, git pop. How do you unstash? Git apply. All right, git. Beautiful language, or beautiful tool, horrible. Oh, fuck's sake. All right, I don't care. I'm going to open a Git GUI and I'm going to delete all the things that are complaining because none of them are important and I don't care about my workspace.json AOC thing. Where is Rockstar? There is Rockstar. A file conflict. Yeah, whatever. Delete the file. Fine. Staging paths failed. Git error. Yes. 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 Right. Where are we? So I get all, yeah, all right, whatever. Yeah, that's fine. Check out that. That's good. That's where we are at. Few changes. So what I'm doing here, I'm just running a build. I'm building the Rockstar WebAssembly engine so that I can fire up the local copy of codewithrockstar.com, bundle exec Jekyll serve. Because on the train home from the Netherlands the other day, I was playing around with a new web-based Rockstar editor which has better stuff in it than the old one, which will make it a little more fun to play around and figure out how stuff works. Blah, 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 blah. Warning, 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 warning. We don't care. That's fine. There we go. Cool. All right. Okay, so what we're going to do is, first of all, I am going to take program.cs day 7. Let's crunch this down into... I need to get rid of the classes and I need to get rid of the extensions. The whole thing just needs to be built out of functions and arrays. So what do we got? Let's try... All right, that's in Git. I can mess it up. It doesn't matter. Stopwatch.that. There's that. Restart. That can come out. That can come out. And so what we're really looking for here is that new equation line thing. Probably we don't want, yeah, without the equation class. I'm looking, what is the data structure we use to store a line here? And it needs to be a tuple of a thing. And Rockstar doesn't have tuples. Rockstar has numbers and strings and functions, and that's it. So we are going to need to, I think, store each line as a string. There's no data structure I can think of that I can parse the line into to avoid having to parse it twice, is the reason why I'm slightly hesitant here. Because it does have, so Rockstar can have lists of lists. So I guess a list where each list is a list, and each list contains. I mean, you can do stuff like this. So you could say, rock the lists, debug the lists. So that's an empty array, and then I can say rock the equation. So the answer is, so let's just pick a random example from, let's pick one of the big ones, one of the crazy big numbers. There we go. So let's, on that one, if we say the answer is that, rock the equation with the answer, debug the equation. Okay, so that's now a list containing a single element, but then you can say the inputs needs to be a list. So rock the inputs will give us an empty list. Rock the inputs with that. And then rock the equation with the inputs. And then debug the equation gives us, yeah, okay, cool. So we got the answer, and then we got the inputs. So we can have lists of lists. All right. I'm liking where this is going. I mean, headfirst straight down the rabbit hole is where this is going, but I like the fact that that's a thing. Okay, so let me grab the example.txt, which is there. Drop that into there. So we're going to build that out into this data structure here. And so we've got listen to the, so that's going to be the line. Let's call that listen to the wind. While the wind ain't nothing. So what do we need? We need to shatter the wind into the sky using and then that lot there will reinstate later. Okay, so that's gonna split that into strings, which is cool. So we want that on there. Now that colon space, we're gonna build that later into something more interesting. So debug the sky is pretty good there. And cast the sky at 0. Using 10 into the answer. Hello! Day 2, part 2 not working for you, but no one is what is for day 7, so back later. I could be here for a little while. We're having fun with Rockstar right now. Cast the sky at 10 using 0 into the answer. Debug the answer. Okay, so the answer now is number 190. So that is doing decimal parsing. Then what we need to do is we need to shatter the sky at 1 using spaces. So Rat's Tail has the toy. Let's just have a look at the toy language. GitHub Rat's Tail 91. Toy. Toylang.com. Welcome to the I'm completely rewriting my language for version 2. This year I completely rewrote Rockstar for version 2. And you can see my discussion of the upcoming changes as well, although mine are historic now because they're done. An imperative bytecode intermediate embedded scripting language. That's cool. Quick start. This guide is intended to get you writing to... Okay, print hello world. We like that. We like that. Variables are variant unless you've specified a type. Oh, there's a pug. That doesn't exist. Do you want me to file an issue? Nice. Oh, that's nice. You can assign slices. So you take the array, remove this chunk of it and replace that chunk with this chunk, even if the chunk is not the same length. That's nice. Anyway, okay, that's cool. I like that. Awesome stuff. Let's go back to Rockstar. Where were we? So, shatter the sky at 1 using that into the inputs. Debug the inputs. I need to cast every element in the inputs. For every number in the inputs, cast the number using 10. We'll turn it into a, yeah. Cast the number using 10, and that will give me a decimal, which means I need to put the decimal into another list. So I need to shatter the winds into the sky, debug the sky, cast the sky using debug the answer, rock the answer. We'll turn that into a list. And then I think rock. Yeah, the debug gets taken out. The point about Rockstar is you've got to get it working first and then you make it cool. Debug is a thing I put in that will dump the variable name, the variable type, and the current value of the variable, and do things like quote strings so you can see what the literals are. So rock the answer at 1. Shatter the sky, cast the number using 10, rock the answer at 1 with the number. Okay, that didn't work. And it didn't work with column 1, line 1, which is absolutely not where the error is. All right. Rock the answer. So let's rock the inputs and using the tokens. For every number in the tokens, cast the number using 10. Rock the inputs with the number. Debug the inputs. And then when we're done, don't debug the inputs. Rock the inputs with the number. That will build that up into the 8. Then we want to rock the answer with the inputs. And then debug the answer. All right, so we take that out. We'll take that out, punch that in there. Okay. Right, so that array there is bad. Functions in Rockstar are, so choruses and verses, there's no unambiguous way to distinguish just from the lyrics what's a chorus and what's a verse. So a Rockstar function is, well, let's build one here. Let's equation takes the line. And so what this is going to do is shatter the line into the parts using that. Cast the parts at 0 using 10 into the answer. So Nano or Steel's helloworld.java it's almost lyrics, like the lyrics to the song are almost perfect code. As in, if you type the lyrics in, there's a couple of points where I was listening to it very closely and I'm like, they are singing some of the punctuation, but not all of the punctuation. I have just had a little nudge about something I was going to check for somebody. Tools, options, no, that's Visual Studio. I want my VS Code. I was gonna check what my VS color theme was. Apparently it's called 2077. That's it. Yes. Right. I just need to reply to a person on the internet. If anyone wants that theme, I'll drop a link in here. There you go. Right. So equation takes the line, shatter the line into the parts using that. Cast the parts, shatter the sky at 1 using that into the tokens. For every number in the tokens, cast the number, rock the inputs with the number. And so that there is going to be a indented block. And tab doesn't work in this editor because it's web-based, and the people who created it have got opinions about what should be permissible. So then we got rock the answer with the inputs. Give back the answer. Okay, that's got an infinite loop because we need to listen to the wind. Let the thing be equation taking the wind. Debug the thing, listen to the wind, and boom, run that. Equation is not a function because it needs to be defined earlier. Only strings can be split. Lies. All right. Debug the line is there. Shatter the line into the parts using that. So that's so far so good. Shatter the... It's not the part. Yeah, there we go. Okay, interesting. It's given back mysterious. There we go. All right. I wonder if there is a... I can't remember if I have an array map function in Rockstar. because there's the whole thing of, do you pull all the this thing for every number in the tokens? Because the other way of doing this chunk of code here is to say shatter the parts at 1 using that into the tokens. The tokens is now an array, so the limit is the tokens plus 0 is how you get an array index. Then you say the index is 0 while the index is less than the limit. Let the tokens at the index be cast the tokens at the index using 10 into the tokens at the index. The index is with 1 and debug the tokens. Equation takes the line. Okay, so there's a glitch in there somewhere. That's that blank line, probably. Nope. Okay. All right, not that. There we go. All right, inputs parsed. Now we need that whole solvable thing. So we got a function here. Solvable takes the input, takes the equation. And what do we got to do here is we got to say if the equation at 1 let the inputs be the equation at 1. If the inputs plus 0, can I do arithmetic coercion in this? Boom. Oh crap, hang on. I've just had an interesting thought. This thing uses browser local storage to store the state of your program, which means if you spin up a new window, I probably need to use session storage, not local storage for that. Session storage is scoped to the top-level browsing context, meaning it's unique to each browser tab window. Okay, a little rabbit hole time. Well, I'm going to dump this into VS Code here. Day 7, new file, math rock. Yeah, why not? There we go. So if I got 2 browser tabs open here, so I go into that one, which is there, and I go into this one here, which is there, and in here I type hello world, and then over here I refresh. Yeah, okay, I need to fix a thing. Cool, I'm glad we found that. So, boom. Yes, code dot end. Session storage, yes, yes. And bundle exec Jekyll server. I think that should mean that I can get live storage in a particular browser tab. So let's take a look here. So we'll reload that, we'll reload that. This is tab 1. Reload that, this is still tab 1. This is tab 2. Reload that. This is tab 2. This is tab 1, tab 2, tab 1. Okay, good. So now I basically have like a MDI type interface, which is, well, I can do multiple browser tabs and have programs running in them side by side, which means if I want to check things, rock my world with 1, 2, 3, debug my world. If my world equals 3, shout yes, else shout no, and yes. Okay, cool. So I can check for array length just by looking at the current, pass the array into a numeric instruction, and it'll give me what I need. So over here, we've got equation takes the line, solvable takes the equation, let the inputs be the equation at 1. If the inputs equals 1, then we've crunched that down to the solvable takes the equation and the operators. Actually, let's set operators. Let inputs be we can put the "thes" back in later. If inputs equals 1 and inputs at 0 equals equation at 0, yeah, I'll need to paste the input from standard in. That's fine. We'll get to that. Give back true. Give back false end. Is that parsable? Yes, it is. So we'll listen to line. Well, line ain't nothing. Let scenario be equation, take in the wind, rock. Let's call that something else. Parse takes the line. Listen to line. Let equation be parse take in line. So listen to the line. Well, in line ain't nothing. So let's rock equations. Rock equations with equation. Listen to line end. Debug equations is an array. I need input in there, as somebody has already pointed out. Day 7, advent of code. There is your example back over here. Run that on there. All right, so I've got an array. 190 is 1019, 32, 67. Yeah, that's that, that's that, that's that, that's that, that's that. And now I can say for each EQ in equations, debug EQ, and that should absolutely not fail there. Huh. Do I not have for each? I'm sure I had for each. Or maybe it's just, I mean, for works. Okay, let me check the docs. Yep. Yep. It's for or for every. There is no each. Okay, that's cool. Who invented this language? Honestly, it makes absolutely no sense. So, all right. There's our math rock. We'll drop that into there. So now what we gotta do is for EQ in equations, debug EQ, and then if solvable, taking EQ, shout solve. That's not the editor, that's the editor. Not enough functions supplied, of course. Hello, Mark. Yeah, putting Rockstar to good use. All right, that one's interesting. Let me just try this, just to test it. If I put 20 in there as 20, and now I run it. Yeah, okay, cool. So that works. 20 to 20, that solves. Okay, so what have I got here? I need to add a functions. So add takes x, y, giving x plus y. Rock operators with add, rock operators with multiply. Can I do that in a one-liner? Look at that, I made a list of functions in a language that I invented in a bar as a joke, and I didn't realize it could have lists of functions. But how, I guess, would it not do that? Because it's got lists and it's got functions, and nobody ever decided to not have that as a thing. Okay, so listen to one line at nothing. So now solve takes equation and operators. All right, that can come out. So now if inputs equals 1 and input and not, and let's just do a naughty check here. If inputs equals 2, it means we've got exactly 2 operators left in our list. Then we'll say if for op and operators, if op taking, if inputs at 1, left-hand side equals inputs at 0, right-hand side equals inputs at 1. For op in operators, if op taking LHS, RHS, let answer be equation at 0. If op taking left-hand side, right-hand side equals answer, give back true. So now that's a thing. So now we've got a loop we need to close here. All right. So that's solved the first one, the array 190. Otherwise, so if we don't bail out at any point in that, this is where we need to do the recursive bit. Let if inputs is greater than 2, that shouldn't do anything bad. Blank lines end things in Rockstar. If we put a blank line in the wrong place. Okay, cool. So that's picking up the things where the input is greater than 2. At that point, we need to do recursion. So we got to say if inputs there is going to be, let's check the rest of the world is doing all right. And if inputs is greater than 2, all you need to do is crunch the inputs down. So rock the thing. Next, rock foo. Foo will do. Naming things is hard, and especially when you know you're going to rename them later. Rock foo with answer, and then what I need to do is this crunch case. So I need to so if inputs is 2, for op-in operators, let crunch be op that can come out. We've always got left-hand side, we've got right-hand side, they're always going to be the same. So if inputs, so let crunch be op taking LHS, RHS. So that's going to crunch those into the intermediate result. And then we're going to rock foo with answer. Then we're going to rock inputs is already taken. Words. Life with crunch. Then we need the skip thing to pull the rest of the things out of inputs. So we got 0, we got 1. So let index be 2, while index is less than inputs. Rock life with index at inputs. Let Interesting. Right, I'm just going to drop in a single case here just so I can see what's going on with it. So 81 plus 40 does yield the 121, but then y is with that inputs at index is what we need. Run that. Okay, so that crunches down that 8140 to 121.27. The problem here is I need a function scope, or I need to initialize a new variable in here because So that there kind of is what we want. It's just it's appending them to the end of the same array. And that'll do it. All right. So that gives me my two kind of recursion cases. And that means that then when I get down to here, I can... what do we got? We got rock foo with the answer. So now if we rock foo with let foo be answer, let life be crunch, rock foo with life, debug foo. All right. Okay, so we got the reduction case here. So that one doesn't work. So now it's going to drop it down into that one, drop it down into that one. And then for each one of those, we need to, if solvable, taking foo operators, give back true. Yeah. Wow. No, surely not. Solve first one, solve it just can't solve the last one. Why can't it solve the last one? And why did I have the same problem solving the last one that I had solving this one? Right, I think I can probably take that out. No. Yes, if inputs is greater than 1, then we do the crunch. But that's no good because that thinks it solved all of them. And that thinks it solved all of them. Yep, 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 yep. 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 All right. That null over there, I'm worried there might be a word solve hidden behind it. I honestly can't see, which means it's probably a problem that shouldn't be there, and so I'm going to take that out, because why not? What are we looking for? Let's look for a right angle quote. There we go. And let's see if I can find custom.css, span.result. There we go. Float right maybe will fix that. And I need input, don't I? Input, 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 copy that. I should probably stick the standard into a cache as well so it survives page reloads. That would be a useful feature to add to this. I just nudged that right. That should be on the right. Why is that not on the right? And that's the wrong window. That's the right window. Span.result, float right. Okay. Is that just not going to behave? Span.result styles, float right does nothing. All right, well, there isn't another solve hiding behind it, so that at least resolves that one. I'm going to take that out. That span result, I think, is just a little... or I can take it off. All right, so online.html. Data controls equals. So the way the Rockstar editor is configured is there's a little enumeration of HTML attributes you pass in to tell it which bits you want it to render. And I don't want all of them. I just want these 5. So there's that one. Spin that into online.html. Data controls equals play, parse, reset, args, input. There we go. Did I just manage to spectacularly lose everything I was working on? Yes, I did. Shit. All right. The problem with web-based editors is you don't get into the habit of shoving stuff up to GitHub every time you do anything with it. All right. Yep. Dang. All right. Yeah. It's all right. I don't remember what it did. All right, so we got parse takes the line, input takes that, and there's the equations. And then we've got add takes x, y, giving x plus y. Multiply takes x, y, giving x times y. Rock operators with add multiply. Be interested in whether there's a better way of managing that particular scenario. Just bear with me 1 second here, folks. I just need to deal with something. Right. Copy to Notepad. Or copy to anything. Yeah, I just forgot to copy. All right, never mind.
Narrator.
Turn off narrator. No, we don't need narrator. Right.
Exiting narrator.
That's what we're working on. So rebuild that. Okay, so that's debugging that. Except it's only reading one line in there. So Notepad, Ratstyle says Notepad is actually a decent tool, simple and intuitive to use. I started my development career using Notepad. My first couple of years as a developer, I used Notepad to write HTML. And like JavaScript and very early days of CSS. And then I graduated from that to TextPad, which was my main editor for about 5-10 years. Like I used TextPad for everything. And then I started doing .NET, and so switched over to using Visual Studio for most things. And then VS Code came along. If solvable, take in EQ operators, shout solve. All right, so there we go. So we got as far as that. And yeah. So what the way I lost my work there is this thing, every time you make a change, it pushes it into browser's local storage. So if you reload the page, you shouldn't, he says confidently, and that's not right. Something in the piping has gone odd. All right, that should be persisted to session storage. But for some reason it's not. All right. Microsoft Flight Simulator 2024 has a built-in narrator, and it happily talks away and tells you what buttons you're hovering over and menu options, but while I play the accessibility, it's a flight simulator. You're not a fan of the idea of visually impaired people navigating aircraft. I mean, I guess if they're going to, it's probably better if they did it in a simulator. I'm sure there are blind pilots out there. Aviation's notable blind pilots. A person who is blind can pilot a plane with the assistance of a flight instructor. There you go. Jim Platzer and Kaya Armstrong were both qualified pilots despite the fact they couldn't see. So, yeah, I guess that's Flight Simulator, just a channel in reality here. Right, inputs. Not that one. That one. Right, boom, run that. Okay, so where did we get to? If inputs equals 1, and then we had the whole, this is the little chunk that we were writing before. So if inputs is greater than 1, now we can assume inputs is always greater than 1. All right. So otherwise, so this is the crunchy thing that we need to do then. So we've got let inputs be equation at 1, let answer be equation at 0. So if inputs is 1 and inputs at that equals, and that can now be answer, give back true. Otherwise, for op in operators, so what do we got? We need to build the next case scenario. So answer 2 equals let answer 2 be answer. Let inputs be op taking left-hand side, right-hand side. So we need to pull out left-hand side, right-hand side. Otherwise, so left-hand side comes in here. LHS, so let LHS be inputs at yep. Let RHS be inputs at 1. Let inputs be op taking a lot. So that's going to be let reduced be, oh, we'll call that result. That can that can do that result be op taking that, and then let limit be 0. No, let index be 0. Be 2. While index is less than inputs, rock result with inputs at index. Index is with 1, and debug. So now we need to create the next thing, which will be, so rock next thing with answer 2. Actually, we don't need that, do we? We can just rock next thing with answer, rock next thing with result, debug next thing. And mysterious. Yeah, not good, all right. Let's try that. So I just saw Mark's comment. Are you rewriting something you lost? YouTube viewers can rewind if you want. Now we're good. I'll figure it out. All right. So if that equals that, let's put in a shout giving it back. And that. Okay, so that never actually kicks in. Otherwise, left-hand side is inputs at 0, right-hand side is inputs at 1. Then let's drop into that. Let's debug result in each one of those cases. Okay, so that's doing stuff. Yep, that's good. That's good. We like that. Okay, better. Yes, okay, so result is now doing the recursive reduction on the array. So while index is less than inputs, rock the result with the inputs at the index, indexes with 1, debug result. That's the right thing. Let the next thing be answer is number 190. Okay. All right. Yep. So that's doing the crunchy thing now, which means we've got... why can't I just do that? All right, so let foo be answer, whatever, rock foo with result, gives us the next case, and then we've got if solvable taking foo operators give back true. Infinite loop. All right, so not that then. That's not quite right. Right, I'm going to knock out a couple of these cases. Okay, so that is doing the right thing. So it's the recursion case that I need to figure out here. So solvable take, let's copy that whole lot and paste it into Notepad and save that as mathrock. All right, so we've got rock result with inputs at index, let foo be answer, rock foo with result, debug foo gives us the whole thing. Yep, let's take out that one there. So run that, okay. If inputs at 1 and that give back true, so I think we've got an early bailout clause there. Okay, so that works, that's good. So if inputs equals 1 and inputs at 0 equals answer give back true, so result, that's inputs at 0, inputs at 1. Let result be operator taking left-hand side, right-hand side. Rock result is fine. Let index be 2. That's fine. Rock foo with result gives me the thing I need to pass into the next iteration of this thing, which is if solvable taking foo operators give back true. Yeah, and that just goes weird now. That mysterious is coming out of, so one, we can stop that. So that's looping. Hang on. If inputs equals 1, then and only then we need to give back false if there's only one thing left and it's not the answer. So if inputs equals 1, all right. Look at that. I think that's right. I think that's got the thing. I think because that's got solve, solve, solve. It's got 3 solves come out of there. Copy that, paste it to MathRock, and save that. And if solvable, taking EQ and operators shout solve. So if that's the thing, so let's say let part 1 be 0. If solvable, taking EQ operators, part 1 is with and shout part 1. Interesting. $3,749. Does that sound familiar to anybody? Where's my Advent of Code window gone? It's somewhere in a browser. It's in that browser. $3,749. All right, let's try it on my puzzle input. And probably take out that debug line, otherwise this is going to get extremely... You ready? See if this works. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's put a guard clause in here. All right, it's working. That's just part 1. But part 2 will be trivial now, because the way that it's put together, you pass a list of operators into the function. Was that a right answer? 538191549. Yes. All right. So that's part one. And so concat takes X and Y, and what does this thing do is it glues them together. Cost X plus Y plus thing. Actually, no, we'll do empty string plus X plus Y into token. So that's our concat function. So then rock operators with concat means that's now got three things in it. Debug operators, just to check we got the right thing. Let me switch back to the sample input so we're not sitting here for ages watching it go wrong. Okay, so we got a closure is that. We got so cast is a parses strings into digits, and you need to tell it the base that you're using to parse it. Cast 100 with 10 into result, shout result. That's not what I expected. There. Using. But if I pass in, say, 16, then it'll parse it using. Yeah, okay. So that width should be a using. 11387. Yep, 11387. All right, let's see if it works on the real one. That window there. That screen there. Copy all the things. Save all the things. Just out of curiosity, Well, that runs in the web-based version. I want a terminal window. I want a ZDay7. Let's do cmd rockstar math.rock from input.txt. Actually, let's do it on example.txt first, see if it does the right thing on there. Yeah, okay, good. So we got the right numbers on both of them. Z is great. Z, Z, Zoxide, whatever you call it. The thing that you get when you press Z, and it goes magically jump you to wherever you want to be. So... Right, let's make this rock and roll. So what I'm doing here is I'm looking at the structure of the program and I'm thinking, is there any sort of reasonable, like what would this song be about if this was a song? And so Z is this thing, Zoxide. Which is just very, very cool. Actually, oh, it's 1:45, folks. I've just seen the time. I need to drop off because I got stuff I need to go and do. But what do we got? We got it working in C#, and I think if we go back over, okay, that is still running, but I think give it time, and it will actually. Song theme is money spent on concerts. You think we can get something out of that? Yeah, I'll probably come back to this later today and just play around with the lyrics a little bit. But the main point is to get the stars. You got to get the stars, folks. Thanks so much for hanging out. That was a lot of fun. Enjoy. I may be back later. If not, I'll be on tomorrow, taking a look at day 8 and getting that one done again in probably in C# first, and then we'll pick the rest up from there. Good to see you, folks.